Hello everyone, welcome back to my YouTube channel. My name is Harshini.P.V, currently pursuing my BE in Sri Venkateshwara College of Engineering, Bangalore. My USN is 1BE23CA021. Section Devo, Subject Applied Chemistry for CSE. Title is Corrosion Chemistry. The contents which we are going to cover today are corrosion, why metals corrode, factors influencing corrosion, mechanism or causes of corrosion, types of corrosion, prevention of corrosion, protective measures against corrosion. Now let us see about the corrosion. Corrosion has been defined as a destructive chemical and electrochemical reaction of a metal with its environment like oxygen, moisture, carbon dioxide, etc., which disfigures metallic products leading to reduction in their thickness and also causes base of useful properties such as malleability, ductility, electrical conductivity, and optical refractivity. Except few metals such as gold, platinum, which are called noble metal, are prone to corrosion. Typical examples of corrosion are rusting of iron due to formation of hydrated ferric oxide and tarnishing of silverwares in hydrogen sulfide laden air due to formation of silver sulfide. Now let us see why does metal corrode. Metals tend to corrode in order to retain their natural form or ore. Metals are usually extracted and purified from their ores via high energy input processes. Example: thermal energy, that is high furnace for iron, electric energy, electrolytic paths for aluminium. Factors influencing corrosion. Corrosion is enhanced by the presence of impurities, air and mixture, electrolytes, strains in metals like dent, scratches, etc. The graph shows the oxygen concentration versus corrosion rate. Mechanism or causes of corrosion. Metals are electropositive in nature. Except few metals like gold, platinum, that is noble metal, other metals are found in nature as their compounds such as oxides, hydroxides, carbonates, chlorides, sulfates, phosphates, silicates, etc., which are called their ore. Metals are thus obtained by extraction from their ores by reduction process. In nature, when metals exist as their compounds or ore, they are stable and they are in the low energy state. However, during extraction of metals from their ores, free metals are become less stable and are in the higher energy state than in the ionic state. So metals have a tendency to back to their ionic state and hence metals are prone to get attacked by the environment. This is the main reason for corrosion of metals. Example is mineral or ore undergo extraction by reduction, forms a metal and thus undergo corrosion and becomes a corrosion product. Factors affecting corrosion. Nature of metal, purity of metal, physical state of metal, position of metal in galvanic series, nature of oxide film, nature of products of corrosion, relative areas of cathode and anode, nature of corroding environment, temperature and humidity, effect of pH, presence of impurities in atmosphere, nature of electrolyte, solubility of products of corrosion. Now let us see about the types of corrosion. Dry corrosion or chemical corrosion. Second one, wet corrosion or electrochemical corrosion. Firstly, let us see about the chemical or dry corrosion. It involves direct chemical attack of atmospheric gases like carbon dioxide, oxygen, hydrogen sulfide, SO2, halogen, moisture, and inorganic acid vapors on metal. Example for chemical or dry corrosion is tarnishing of silverware in hydrogen sulfide laden air. Secondly, let us see about electrochemical corrosion or wet corrosion. It occurs due to setting up of a large number of tiny galvanic cells in metals in presence of an impurity as well as in presence of moisture. Generally, impurity or more active metal act as anode and original metal act as cathode. So, anode is the area where corrosion occurs. Example, rusting of iron in moist atmosphere. Prevention of corrosion. There are many methods of protecting metals against corrosion. First one, barrier protection. Second one, sacrificial protection. Third one, cathodic protection and alloy formation. Firstly, let us see about the barrier protection. Here, a thin barrier is developed between the surface of iron and atmosphere by one of the following methods, that is, painting of the surface or coating the surface with a thick film of some non-corrosive metal like nickel, chromium, copper, etc. Coating of metal. In order to prevent corrosion, resistant coating is made between the metal and environment. Different types of metallic coatings are galvanizing, that is, thin coating of zinc on iron; electroplating, that is, coating of copper, nickel, or chromium on iron with aid of direct current; tin plating, coating of tin on iron; shearodizing, it consists of dusting of zinc powder on iron surface followed by heating. Next, cladding. Prevention of corrosion. Alloying the metal. Metal has better resistance to corrosion after forming alloy with other metal. Example, stainless steel, in which ordinary steel is alloyed with chromium and nickel. There are two kinds of alloys, homogeneous alloys and heterogeneous alloys. Firstly, let us see about homogeneous alloys. Homogeneous alloys are solid solutions in which components are completely soluble in one another. Example, stainless steel. Heterogeneous alloys. They are the mixtures of two or more separate phases. The components of such alloy are not soluble and exist as separate phase. Solid solution alloys are more corrosion resistant. Chromium is used as alloying metals for iron and steel. Silicon is used in making silicon and iron alloy. Now let us see about sacrificial protection. In this case, the surface of iron is covered with a more electropositive metal like zinc or aluminium. Since this metal loses electrons more readily than iron, rusting is prevented. As long as metal is present, iron does not get rusted. This type of protection is called as sacrificial protection. Cathodic protection or electrical protection. It is protection of parent metal from corrosion by connecting with a more active metal like magnesium, aluminium, zinc, etc. The more electropositive, that is active metal, acts like anode that supplies electrons, and parent metal acts like cathode that receives electrons. Thus, connected metal undergoes corrosion, thereby protecting the parent metal from corrosion by turning it as a cathode. Hence, the metal is called cathodic protection. Protective measures against corrosion. Metallic coating. Electroplating. It means a coating metal is deposited on the base metal by passing direct current through an electrolytic soil. Metal cladding. The base metal to be protected and coating metal are sandwiched by pressing through rollers under the action of heat and pressure. Hot dipping. The base metal to be coated is immersed in a bath of the molten coating metal. Cementation. A uniform surface coating is obtained by heating the base metal in a power of coating metal. Metal spraying. The coating metal in molten state is sprayed on base metal by means of spraying gun. By modifying environment. By lowering the temperature, by reducing the moisture, by reducing the acidic corrosion environment. Next, proper designing. Proper designing of the equipment. Avoid the direct contact of dissimilar metals. Electrochemical protection or cathodic protection. Sacrificial anode protection. Metal to be protected is connected to more anodic metal to avoid corrosion. Impressed current cathodic protection. This process consists of connecting the material to be protected to negative terminal of DC source and positive terminal of DC source is connected to an insoluble anode. The current supply is in opposite direction to the corrosion current. Thus the metal to be protected act as cathode and get protected. Thank you for watching the video. Have a nice day.